Dijkstra's algorithm was derived by a Dutch scientist, Edsger Wijb Dijkstra, in 1956 and it was published in 1959. Dijkstra's algorithm is a solution to find the shortest path between two given nodes in a graph. This algorithm, also known as greedy algorithm, works on the principle of calculating the shortest path between that vertex and every other vertex. The most common use of this algorithm is in Google Maps to find the shortest distance from one place to another.
Let's look at the working principle using a real-life example. Vertices of the graph represents walking distance between the building of SRM by direct connected road. Dijkstra's algorithm can be used to find the shortest route. Now, Arnav and Arpit are standing at the SRM gate. They have to pick up their Amazon packages from M block. Now, Arnav started his route by going from the main gate to boys' hostel, then taking the temple route to the M block to claim his Amazon package.
Now Arpit, who is still standing at the main gate, decided to apply the Dijkstra's algorithm in order to find the shortest path. To do this, we first select the main gate as the source vertex where Arpit is standing. Then we have to label the distances which are directly connected to the source vertex, which are the university building and the boys' hostel. Hence, the university building will be 50 meters from the source vertex and the boys' hostel will be 100 meters away. Other places will be marked as infinity since no direct path is there from the main gate. Now we have to select the shortest direct path from the main gate. Out of the boys' hostel and the university building, the UB is shorter, so we select UB. After selecting this, we have to perform relaxation and see the vertices connected to UB, which are the tech park and the boys' hostel. Now we check the distance for the boys' hostel. 50 plus 40 is less than 100, so we modify the distance of boys' hostel from source, which becomes 90 meters. For tech park, 50 plus 150 is less than infinity, so we modify the distance for it to become to 200 meters. Now we again perform the repeating steps. We check the smallest path from the UB, which is to the boys' hostel. Now we perform relaxation and see only one vertex is attached, that is the M block. Now 90 plus 60 is less than infinity, so we modify it. Since we have reached our destination, the M block, that is 150 meters away from source via the shortest path, Arpit will now use this path to receive his
I
package.
would like to quickly expand on one feature of the algorithm. What you see here is the formula which performs relaxation on the graph. We are taking the starting node, we are comparing the distance between that and v with the distance between that and u plus the cost of traveling from u to v, which is basically the distance from u to v. If the second distance turns out to be lower, then we swap them. In more concise terms, we are adjusting and verifying the shortest distance to a given node every time we travel through a new path. This process, called relaxation, happens on every single iteration of the algorithm. To calculate the time complexity of this algorithm, we have to square the total number of vertices.
Dijkstra's algorithm isn't perfect. Being referred to as the greedy algorithm, it faces various drawbacks, namely, since it performs blind, unguided search, it takes a lot of time. Moreover, the negative edges are not compatible with this algorithm. A negative edge makes the graph traversal acyclic, often leading to incorrect solution. With this, we would like to conclude our presentation. We hope you were able to get a clear picture and we implore you to find more methods to go about the same problem. Thank you for your patience. Have a great day. Happy New Year.